不然先删掉它。它不是可以先移除吗？
对，
那就先移除吧。
然后现在
然后再加，就加这个。
也没地方放那个码。
那先 save。
诶，这是可以了。Hello, can you hear me? Okay, so it's 3 o'clock now, so let's start our today's training. Today our topic is about axis group control, and I will introduce this function through these 3 parts. First, let's check what's the axis group. An axis group, you can understand it as a collection of many motion axes. And we can use the axis group to control these multiple axes together to complete some complex motion. And it has synchronization between the axes in the axis group. For example, we can create one axis group and add 2 axes, x and y, and to do this circle interpolation movement through the motion function block. And our axis group also have some control status, which is similar to single axis. And this is the different control status of our axis group. After power on the axis group, the status will change to this group standby. And if you use some function block, for example, MC home group home, it will change to group homing status. And if you use group stop to stop current movement, the group will change to group stopping status and finally go back to this group standby status after the stopping operation is finished. And now I will introduce how to create an axis group. To create the axis group, we need to first add one axis group in this project management. Here you can see this axis group setting. You can right click to one axis group. And the next step, we need to add axis to this group. For now, our A500 support this Gantry axis group. So you can do the 2 axis or 3 axis interpolation. So here we need to bunch at least 2 axes, x and y. And there are 2 ways to add axes. One way is you can directly here in axis group to select the axis to bind to different direction. And second, you can use this MC add axis group, this function block to add the axis to the group. Here have 4 import parameter. This group ID, you can check it in your group here. Axis group number, this is your ID. And axis ID is, you can check here in motion control axis. And for the index axis, index ID, it means for example, if the index ID is 0, it means x-axis. If it is 1, it means y-axis. 2 means z-axis. So, for example, if you want to create it, you want to add one axis to z-axis, you can set this index x2 and the group ID as this 0. And also we can use this remove axis from group, this function block to delete the axis from the group. And this parameter is same. after we add axis to the group, we need to enable the group to do the for example, interpolation operation. And here have one point to notice. Before we enable the axis group, we need to enable axis first. So, for example, you add axis 0, x1, x2 to this group. You need to first use MC power function block to enable these three axes, and then use this group enable function to enable the group. And also, when you use this function block, add axis to, for example, if we add axis to this index 0, if here have already bound another axis, and you use this add again, you will get an error. And also, for example, there have no axis in index 0, and you use this delete axis from index 0, you will also get an error. And this two function block is used to stop the current movement. The difference is if you use this group stop, this function block, the movement will stopping and the status will change to this group stopping status. And when you, for example, when you disable the MC group, the axis will change to this group standby status. But this helps. This will not make the axis enter the stopping status. If you disable this function block, the axis can continue to move. This is the difference between these two stop and held. Okay, and now I will introduce some function block about the movement. First, also we can use this. We have these two function block: read group actual position and read group actual velocity to get the group position and the velocity. Here have let's look at this input parameter. Here have this code system. For now, we only support decar code system. So for this parameter, only support 0 now. You don't need to you don't need to change this parameter. Okay, and also for this velocity, also have this only 3 inputs. And the output here position. This position is an array data. So you need to bind one. You need to create it an area data and bind it to this position to get the position of different axes in the group. And also for this velocity, we can get two velocity output. First one, velocity is also an area data type. You can check the different. You can check the velocity of different axes in the group. And for this path velocity, this is the you can understand it as an 3 axes combined speed. For example here. Yes, for example, if here we move from 0, 0, 0 to 505 with the velocity 10, and here we will get a different velocity of different direction. For x and the x and z direction, the speed will be 7.071. And for y direction, because we don't have the movement on y direction, so the speed is 0. Okay, and now I will introduce these two linear interpolation and circular interpolation. Here, for example, this move linear absolute function block. We also have a move linear relative function block. But here I will only introduce this one. Let's check the input parameter. First, the position. This position is an area data of long rail. For example, if you add 3 axes in your axis group, and you need to fill in the target position of x, y, z 3 direction in area 0, area 1, position 0, position 1, and position 2. Okay, and this velocity is the resultant velocity of the linear movement, just like this one. You can also understand it's an line speed from here to here. And some other function block, some other parameter, acceleration, deceleration, and jack. For the buffer mode is used to connect to continue function block, and we have different buffer modes to connect to function block. We can open the project to check it. Okay. So here I have already add axes, 3 axes, x, y, z to the axis group x, y, z. Before enable the group, we need to enable 3 axes first. Use this with this x enable. X enable is 3 is MC power. So we can enable axis first. And now we can enable the group. Okay, you can see here this down terminal is turned on, means we have already enabled the group successfully. And this rate group position and rate group velocity is also enabled, because I use the flag of group enable for the enable signal of these 2 function block. And I also have already added this group position to our monitoring variable window. You can see the correct position of x, y, z is 5, 5, and 0. And this linear interpolation, we can set the target position, for example, 50, 60, and 70, right then to the target position. And set the running velocity, for example, 10. And now let's run this linear interpolation. The position is changing now. We can get the velocity of different axes and the position of the. Now we have already arrived in the target position. Okay, so this is the usage of the absolute linear movements. For the relative, the only difference is the target position is relative target position. And next, let's check this circular interpolation. And also, I will only introduce this move circular absolute. Some input parameter is same to linear interpolation. Some difference, for example, here, the velocity of the circular interpolation is the linear speed of the circle. You can check it in this picture. And here, we need to define the circle we need to draw. So we will have this x point and end point, and also the start point. The start point is the current position, so we don't need to set it. And also some other selection, for example, path choose this function, this parameter. So how to use these three, and also this circle mode, we can understand it with this picture. We have three modes to define one curve. For example, if the sec mode is 0, then the curve is defined by the start position, x point and end point. So here the x point is the point on the curve. So we use 3 points to define one circle curve. And in this mode, we don't need to set this path choose, and also have some limits. For this, when you use this mode, the angle of this curve should be less than 2 pi. And the second mode is this center mode. We need to set the sec mode as 1. And in this mode, the curve is defined by the start point, end point, and the center point. Here the axis point is the center of this circle. And this path choose is to choose the different direction of curve. For example, when the path choose is 0. No, sorry, this is 1. This is 0. When this parameter is 0, then the curve will be this one. If this path choose is 1, then the curve will be this one. different direction. Yes, this is the second mode. Second mode to define the curve. And also we have the last mode. We call it as diameter. And we need to set the parameter, set this circle mode as 2. In this mode, we use this normal vector of the plane containing the circle. How to understand? Also, we have one start point and one end point, and we need to use this axis position to define the direction of the circle, and the length of this normal vector will be the radius of the circle. How to understand? For example, if the position of this point is, for example, 5, 0, 5. So the length of this will be this value, and this will be the radius of the circle. Okay. And also in this mode, this path choose is used to select the different type of the axis. It's main axis or mesh axis. And usually we use these two modes. Okay, here. For example, if you want to draw this curve, our start position is 0, 0, 0, and the end position is 5, 5, 0, and the center position of the curve is 2.5, and 2.5. And here we can see the direction of the axis is of this curve is CCW direction. So to draw this curve, we can set parameter like this. Here, we need to first set this parameter as 1, and set the path choose as also as 1. And as for this axis point and end point, it should be 2.5, 2.5, and end position is 550. The start position is start from 0, so we can use linear movement to move to 0, 0, 0 first. Set a new target position. and begin to move. Okay, now we are in the start point. And we can use this circular move to start the movement. We have already arrived in the target position because the target speed is big. So we move to this position quickly. Okay, so this is our today's content about axis group control. And thanks for your attending. And our next training will be next Wednesday about the expansion module applications. Welcome to join it with us again. And now if you have any questions, you can type here. Let me check. What's the easiest way to acknowledge two axes along a curve to cut? What's the curve you want to cut? Is a linear curve or some other curve? If you just want to acknowledge two axes, for example, with the same speed or a fixed speed ratio, we recommend to use e-gear function because the response speed of e-gear is fast. But if the curve is, for example, is complex, it's better to use to create it and can table and use eCan to do the signal race. Okay, do you have any other questions? If we don't have any other questions, our today's training will end 2 minutes later. Okay, here I have no other questions. So goodbye and see you next time.